Continuing from the previous scenario, I have added 4 questions, which are questions 3 through 6. What is the slope? What is the y-intercept? What is the domain? And what is the range? I want to answer these questions directly and also interpret what these things mean: slope, y-intercept, domain, and range. All right, so we have a function. Here's the function we came up with. And this function is in y-intercept form. Let's include that so we can match the real-life scenario and our thinking with the algebra that you will see. Y equals mx plus b format. M is the slope. B is the y-intercept. Now, concept of slope. Again, we want to look at rate of change. So slope, rate of change. Cannot overemphasize that. Right. In this situation, I am running faster as each week goes by, so my performance improves. But running faster means my speed goes down. -7, you will see, is in the position of the slope. Speed is -7. That makes sense for running faster. So the slope equals not -7, -0.7. And that's seconds per week. Speeding up by 0.7 seconds per week. The y-intercept. Y-intercept is always your starting amount. Y-int is starting, or initial, or original, or might go off the page, beginning amount. How fast or how well did I perform at the beginning of my training? And that is 56.4 seconds. My current time in the beginning was 56.4 seconds. So the y-intercept equals 56.4. The units would be seconds. For the real life problem, you always have units. Now let's look at the domain and let's look at the range. When we're speaking of functions in general, our domain is our x value and our range will be our y value. The domain is what you put in, also known as the input. And the range will be what you get out, also known as the output. What you get out depends on what you put in. That makes this dependent. The y value or y variable is dependent, then the x value or x variable is independent. What you put in controls what you get out. What can we put in? We're putting in values for how many weeks I trained. The lowest W can be 0. So my W has to be greater than or equal to 0. And I get that from when I start. And since I'm going to train 12 weeks, my highest W can be 12. So how do I unite W being greater than or equal to 0 but being less than or equal to 12? You can say 0 to 12 Since these are inclusive, you will see brackets. Let's make that parenthesis go away so there's no confusion. Since these are inclusive, you can have a value of 0 for the input, you'll have a bracket, and since you can have a value of 12 for the input, you have a bracket, 0 to 12. That also looks like 0 will be less than or equal to my weeks of training, and my weeks of training will be less than or equal to 12. That takes care of the domain. And what does it mean? I can train as few as 0 weeks, I can train up to 12 weeks. Now, our output. Since I'm going to be improving my time will be going down. So my highest time will be 56.4. My time will be less than or equal to 56.4, and the time we annotate with a capital T. And as I work my way down to 48 seconds, that will be my lowest time. Be nice to even go faster, but this accomplishes the goal of the problem. That will be our domain. Since it includes 48, I'm going to put 48.0 even. Use a bracket, and the highest 56.4. Although I'm starting at 56.4 and working my way down to 48.0, this is bracketed from lowest to highest values. That will be the range for this function. Last thing I'd like to look at, we've answered those 4 questions, is let's read, get a little better understanding of our function. This is read, the function t based on w, commonly read t of w. Again, that's the function t based on w equals negative 0.7 times the weeks that we input plus the initial value of time, which was 56.4. This left-hand side of the function before the equal sign, there is no math or algebra to perform. That's just the function t based on the input values w. So that's describing the function. The output will be t, the input will be w. Thanks for watching. Look forward to seeing you in my next video on linear equations, linear inequalities, and linear functions. Again, this is a linear function because there was steady change.